What is up, everybody? Welcome to Elasmocast. Today we have a really special guest. We have the Australian paleontologist John Long, who most recently has been in media for this book right here, The Secret History of Sharks. So yeah, we're going to be discussing that, and we're going to be discussing all sorts of different chondrichthyan related topics. So how are you doing, John?
I'm good, thanks, Ben. Very good.
Yeah, so you just came out with this book. So I was curious, what's your writing process like? Because I think I heard that it took you like 4 years or something like that in the making to create this. And obviously paleontology things move really fast. So like for
Yeah,
example, you discussed Tychodus.
yeah.
Tychodus being a lamniform was described, in April of 2024.
Yeah.
So there must have been a lot of different things you had to constantly fact check.
Funny you should mention Tychodus. It was the very last thing that crept into the book. I had to beg with and plead with my editor because the book was just about to go to press
Mhm.
almost that week. So
Yeah.
let's get back to the writing process, then I'll tell you the Tychodus story. But fundamentally, I got approached out of the blue by someone, an agent in New York, that identified a book that needed to be written, The History of Sharks, because no one has ever done it properly as a popular book. There's been
Mm.
some academic kind of books. Um, and there's lots of other shark experts that are far better qualified than me. But they
Mhm.
chose me because I'd written lots of other popular books and asked me to submit a sample of my writing. They liked it. And so they gave me a contract. And from there, it took 4 years of just heads down, uh, researching all the literature and getting up to speed with it. My background is as a fish paleontologist that specializes in Paleozoic fishes, and I
Mm.
have published about a dozen odd papers on fossil sharks. So I'm kind of familiar with Paleozoic sharks very much. Um, but in the course of writing, I took a kind of gonzo journalism approach, like a Hunter S. Thompson approach, that I
Mm.
immersed myself into the story as much as possible. So it could be more about storytelling rather than scientific facts. So
Yeah.
when a scientist writes a book, it's always like obsessed with detail. There's got to be so much detail in it. You've got to have every little detail in it. So I kind of did that for the first draft of the book, and it was way too big. It was
Yeah.
about 170,000 words or something for what was
Mhm.
meant to be a 100,000 word book, 120,000. So it was cut, cut, cut. And then the mission was reshaping it to focus on the big overarching story and not get bogged down in too much detail. And that's the end product that you finally saw. But it's funny that when you write a book like this, you're always obsessed with the new papers coming out all the time.
Yeah.
And I was very, very lucky in that sense because I already knew most of the world's leading fossil elasmorant workers as friends and colleagues from conferences and working in museums. So I was able to approach them and ask them about new research coming out. And that's where I got the heads up on a number of papers that were in press or about to come out, especially regarding the Megalodon chapter, which we'll talk about
Yeah.
later. But Tychodus was a classic example because I was recording the audio book that week, and we are reading that chapter, and then the paper came out, and I go, "Oh my God, this is fantastic new paper by Roman Vullo and his team about this amazing new discovery of Tychodus from Mexico. Whole complete specimens with a dentition, showing
Mhm.
it's a lamniform. We never expected it. And so I begged and pleaded with my editor at Random House, and she let me take out 48 words and put 48 words in. So I exactly extracted what was wrong that I'd written about Tychodus and put in just 48 precise words saying a new discovery's been made and we know it's a lamniform and blah, blah, blah. So that was the very last thing I put in before the presses rolled and the book went to print.
Mhm. That's really cool. And to me, one of the best things about this book is there's so many different paleontologists that really don't get the press that I feel like they deserve. Like, for example, you mentioned like Wayne Itano, JP
Yeah,
Hodnett, David
yeah,
Ward, all of these people that,
yeah,
like, if you're in the scientific community, these are big household names for chondrichthyan paleontology. But the
yeah,
mainstream media really doesn't, for the most part, have access to them or really know their stories because it's more than just their work. It's who these people are that's really
yeah,
fascinating, how they came to be and all of that. And then
yeah,
the fact that you can just go to Barnes and Noble now and read a book that mentions like Draco Pristis
yeah,
and
yeah,
Tychodus and
yeah,
all of these different chondrichthyans that like outside of this, nobody really talks about in the mainstream media. So I
Exactly.
think
It's
that's
about
really cool.
Megalodon. And yeah, well, one of the things is I've met and known these people. David Ward's been a close friend of mine for over 30 years. I've stayed at his house when I was young,
Hmm.
and he's come and stayed at my place as well. So it was all about me being the presenter to present these wonderful people that do amazing work and give them the full credit for the work, rather than being one of these writers that doesn't mention anyone and sort of says, well, someone made a discovery about this and I think it's great, but
Hmm.
doesn't mention their name. Because some writers do that. It's all about them, And for
Yeah.
me, it wasn't. It's all about showcasing young and up and coming researchers, a lot of the younger people, as well as the old brigade that have done classic and amazing work. And what I
Yeah.
did was I interviewed them all like we're doing now on Zoom, or went over and visited them and stayed at their house like I did with David Ward and just picked his
Hmm.
brains for 3 days up in the shark room. He's got an amazing house with a whole office full of shark's teeth from all over the world. And we were
Yeah.
pulling out teeth from Kazakhstan and looking at them, and he was telling me his Megalodon story of the
Hmm.
rise of Megalodon. And so it was this wonderful collaboration between people. And I even went a step further than most popular writers. Most people that write popular books just kind of write the manuscript and give it to their publisher for editing. I actually got every chapter of the book reviewed by an expert in that particular field, every chapter.
Hmm.
So, for example, Mike Coates, who is as you know, a wonderful Elasmocast researcher from University of Chicago. He
Hmm.
read 3 of the chapters on Paleozoic sharks. And Jürgen Kliwet read the chapter on Triassic sharks. And John Maisie read the Jurassic sharks. Michael
Hmm.
Siverson, Cretaceous sharks, and so on.
Yeah.
So I made sure that every chapter was checked for factual accuracy, and then it went to the presses. So I'm very, very happy with the final product, and I'm glad you've picked up on the human story, because it's not just about the fossils, it's about these amazing people and how they made their discoveries and how their lifelong interest in fossil sharks began.
Hmm. Yeah, and another aspect with the human story is not a lot of people really understand what it takes being on the field sometimes. Like, for example, when I read your publication in 1995 with Young about the Antarctica
Yeah.
Paleozoic shark or chondrichthyans that you found, you don't really think of the stories that you just like bring up right in the front of the book. You think of, okay, they were probably just on the field, they picked up a couple teeth and they wrote the paper, but you don't really grasp the stories behind it.
Yeah, well, as you know, in the opening chapters of the book, I nearly lost my life on that trip, but
Mm.
almost falling down a crevasse, and my feet broke through an ice bridge. And I was by myself, and I made it up onto the Portal Mountain where Portalotus comes from.
Hmm.
This amazing big shark from the Middle Devonian, like probably the biggest shark of the Middle Devonian, at least 10, 12 foot long.
Hmm.
Um, but on that same trip, which lasted for 3 months, sledging through unknown territory in Antarctica, I actually counted up. I nearly lost my life 4 times with accidents and near misses with skidoos and nearly falling off a cliff and things like this. So yeah, that times in the field can be very treacherous. I wrote the entire story of that expedition up in one of my earlier books called At the Mountains of Madness, a journey through an odyssey through Antarctica. No, a journey through the mountains of madness. That's right, because it's based on the H.P. Lovecraft book At the Mountains of Madness, which
Hmm.
parallels it in the same story.
Hmm. And what would you say is probably your all-time craziest experience on the field? It could be in this book or it could not be. Just like what do you think is like your go-to, bar story experience?
Well, definitely the opening of the book, nearly falling through the crevasse by myself, and then because the end of that story, and it's free on the internet, anyone can read the first few pages of the book or hear the audiobook, me narrating this story personally, is
Mm.
that I'd been walking to the camp, from the camp to the mountain, and it was a New Year's Day, and we'd been celebrating the night before, and everyone else was resting in their tents. And they said, "Oh,
Mhm.
it's only a short journey to that mountain, so I'll go over there, have a look. It's a famous fossil site from collected 20 years earlier." And as I was going through, the snow got deeper around my waist, and then I broke through and felt this feeling of kind of falling but thrashing to the side, and I made it, and there was like a crevasse below me. So I very
Mhm.
carefully made my way onto the mountain, and then I'm trying to get across a ledge, and it had been snowing nonstop for 10 days, and then looked up and saw snow whizzing down past me. I got hit by a very small avalanche. It kind of knocked me off my feet, buried me up to my neck. I still have photos of these sites actually in my old slide collection. But then I got back to the camp by safely tracing my steps. And the next day, our survival expert, who's our guide, to get us safely onto the fossil sites, he
Hmm.
walked across my path with a crevasse probe,
Hmm.
and he discovered I'd walked over 7 crevasses, 7, and just broke through one. So to this day, I count my lucky stars. I'm actually still here. So that's the opening story of the book, and also I think my best bar story about fossil hunting.
Yeah. Yeah, I mean, again, like I never would have guessed that things like that would have happened on the field just from reading the publication. So there's definitely a whole nother realm of aspects to the job than what you just see in the literature or you see in like the job descriptions. And what's your process usually, or what's the process when it comes to you getting these like gigs in like Antarctica, for example, or you travel like all across the world, as you say in the book. Like as a paleontologist, what are the steps that you take before you go on such expeditions?
Well, the first trips to Antarctica, Ben, were just purely coincidental because I was just out of my PhD, a young sort of researcher,
Mhm.
and I went to a conference in New Zealand and presented on my work on Devonian fishes, Victoria of Australia. And at the conference were some New Zealanders who'd been working in Antarctica on the Devonian, looking at the stratigraphy, the geology, the invertebrate fossils. But they
Mhm.
had no one on their team or no one from New Zealand that knew anything about Devonian fishes. And they'd just discovered a new series of outcrops in the Cook Mountains that no one had ever mapped or been to before, and it was rich in fish remains. So they said, look, we need a fish paleontologist, and we're going back continuously. Do you want to come with us and join an expedition, and you can collect the fossil fish and shark remains? I said, yeah, absolutely. So that was the first expedition in '88, which was a bummer really because we didn't get into the field because there was a logistics accident with a helicopter, and I was stuck on base for like a month. I did get out to the dry valleys, but there's no fish fossils there. But I looked at Devonian outcrops. So we ran the whole expedition again 3 years later, and that was the big 3 month expedition where we're airlifted into the remote locations on a Hercules aircraft. And then we just sledged with pulling sledges and putting up tents all the way, exploring new outcrops, collecting fossils, and just moving through about 500 miles of unexplored territory. And that was the big expedition where I discovered all this new material.
Hmm. Yeah, it's really cool. Like a lot of people I think they think of paleontology kind of like Indiana Jones traveling around the world. And a lot of
Yeah,
times I kind of think to them, well, most of the job is sitting down on your computer, doing research or things like that, or writing, grants and all or grant
yeah, yeah,
proposals, things like that. But then you
yeah.
read stories like yours and you're like, you know what, maybe there is like an Indiana Jones aspect to it, to the adventures.
Possibly. I've been back to Antarctica 4 times. Like I went 2 expeditions recently with Neil Shubin and his team that wanted to go back and search for Devonian Tiktaalik-like fishes in the same outcrop. So I went down with those guys, and we got lots of new stem tetrapod remains that we're still working on actually. And I was in my 60s on the last trip and still climbing the mountains with a full pack, but very wary this time about all the dangers and not taking any unnecessary risks. But I love field work. It's what gets me up in the morning. And I've just come back only last Friday from 2 weeks up at Gogo in my
Hmm.
fossil site up in the Kimberley, which does feature in the book with all these new discoveries about not only a Devonian shark I found there called Gogo but also of incredible placoderms that inform us about the evolution of sexual reproduction and how placoderms invented it and kind of passed it on to sharks, all that kind of stuff.
Yeah, and that kind of ties us into what I think is the most intriguing section of your book, which is the Paleozoic era, because
Yeah,
that's really where you see the most diversity in like the higher ranks of chondrichthyans. And then you have those really crazy animals that there's nothing like them today, like the placoderms. So,
yeah.
so what would you classify as a shark? Because every paleontologist seems to think of something different when they think of a shark.
That's a very good question. It's still a hard one to answer. I mean, I go back to the fact that they have a highly specialized kind of cartilage, globular calcified cartilage
Hmm.
with tesserae. And that seems to be a unique kind of cartilage that only sharks and shark-like things have. But
Hmm.
then we get back in the fossil record, and of course, something that's a novelty has to evolve along the way, and usually with stepping stones. So you get strange intermediate forms in the Middle Devonian, some of which have the definite impression of calcified globular cartilage, like some of the Bolivian fossils, like the ones from Zamnopterygion and Pucca things like that, and others that don't seem to have that or have that cartilage but have a different type of tooth arrangement, like Pucca.
Hmm.
Other defining features of sharks, apart from the cartilage, is of course then it gets deep into the anatomy of the brain case and the teeth. The fact that the teeth are always erupting and being replaced, but then we have examples of other sharks that didn't do that, or
Hmm.
sharks that coalesce their tooth into tooth plates, like holocephalans or rays. So for every thing that's a good, what we call a synapomorphy or a defining feature of the chondrichthyans, there is always an exception at the beginning of the lineage. And it's the same with bony fish and placoderms and any group, even mammals or reptiles. You'll find that the vast majority of them share some solid features that define them. But as you get towards the beginning of the clade, there's always exceptions and always taxa we don't know where to put them. So sharks are the same. I don't think the evolution of sharks, that their relationships is fully resolved yet. I think
Hmm.
because the first 50 odd million years of sharks is only known from a handful of scales and bits of spine, and teeth don't even appear in the record till the Devonian, or apart from tooth whorl like things like Chianotis in the Silurian. But
Hmm.
actual teeth that are replaced in rows don't appear until the Devonian. So we just know so little about the early evolution of sharks that, the big question is, currently placoderms are seen as to be the ancestor of both sharks and bony fishes.
Hmm.
But this discovery of this shark from China, Shenacanthus, which is like a shark-like creature with definite dorsal fin spines that
Hmm.
are akin to the stem sharks, which we used to call the acanthodians, but clearly not a bony fish type structure. So
Yeah.
it's got that definite chondrichthyan feature, but it's also got bony plates around the head and body like a placoderm. So to me, and I suggest very cheekily in the book, that as we learn more about these early forms, it might reveal that sharks came before placoderms and just shed their bony armor to become sharks. That's an option, but it's not the leading theory at the moment. But it's still an option. It's still on the
Yeah.
table.
And
So I think it's exciting times that we haven't really resolved this question. And I think in the next 10 years or so, with these discoveries coming out of China, we have every chance of resolving it quite solidly.
Yeah, the Chinese fossils really are groundbreaking, like those two that you just said. I personally lean towards that latter hypothesis that you gave
Yep.
because
Yep.
to me it makes more sense, especially when you find the chondrichthyan-like scales within the Ordovician, yet there's really no
Yes.
trace of anything from placoderms until
I
the
agree.
Silurian.
I
So,
agree 100%, which is why I suggested it, because we've got not just one or two, we've got at least five different kinds of sharks by the end of the Ordovician, and some of
mhm,
those placoid scales, like the Tantalipus ones from Central Australia, with the three ridges, are so similar to some of the placoid scales of living sharks that
mhm,
they have to be shark-like creatures at that age, well before the earliest placoderms. And so,
yeah.
there's all these like gaps in the fossil record that we haven't resolved yet.
And are there any placoderms with similar scales, like shark-like or chondrichthyan-like scales?
Absolutely not. I mean, the earliest placoderms we know of, scale structures that have been studied, they have like bony layers of bone with trabecular bone, and they don't have the same tissues as sharks. They have their own kinds of dentine, like semidentine, that only placoderms have. They don't have the shape of the placoid scales with a flat base. They tend to have just flat, bony plates, which are
Mhm.
thicker, not thin. So there's no evidence of placoderms showing shark-like scales. It's more like you could derive a shark scale from either an earlier Thelodont scale, which I show in the book, just by adding neck canals. And Thelodonts go right back to the Ordovician as well as sharks. So
Mm-hmm.
Thelodonts and sharks appear well before placoderms and then bony fishes. So, you
Mm-hmm.
know, anything's possible as we find more discoveries from this age. I think it's the most hottest thing right now in vertebrate paleontology is to find more Ordovician vertebrates and resolve some of these big questions in the early tree of vertebrates.
Yeah, yeah, for sure. And then another interesting thing too is if we think about in the Ordovician where there are scales, but there is no evidence of any teeth there. And
Yeah,
then we don't see teeth from, osteichthyans either. But then in the
yeah,
Silurian, you see tooth whorls of what
yeah,
is probably already, your derived chondrichthyes compared to the lineage that would have brought your osteichthyans. That means
yeah.
that both lineages possibly developed teeth independently of one another, and that they convergently evolved in new worlds, and then from there into what we now know as teeth.
That seems like a good idea, a good theory, actually, because way back in 2003, Moya Smith and Zarina Johansson in London published a paper in Science about placoderm teeth, saying they had two origins, even within placoderms. And even though that's been sort of shot down now, and we see placoderms as having one origin, it is the difference in the way the teeth are made
Mhm.
structurally. And these new papers published only in the last couple of years about placoderms from Prague having tooth lots of little tooth plates on the margin of the cheeks shows that the teeth evolved from outward from the dermal skeleton coming into the mouth seems to
Mhm.
be the most likely origin. And that fits sharks as well, because as we all know, the placoid scales are histologically almost identical to teeth. Just you to change the proportions a little bit and you can get a tooth from a placoid scale kind of thing.
Mhm. Yeah, and you can read a lot of the like odontode hypotheses and things like that where it just like comes inward basically into the jaws. And I find that really fascinating, but I also find fascinating that there was still likely some lineages within chondrichthyes that, didn't evolve these teeth at all, that
Yeah,
could have either lost teeth or they could have never evolved them to begin with. Like you have, especially within, some of the acanthodians, some of
yeah,
them didn't have teeth.
absolutely. A lot of the ones from the moth locality in Canada, Lupopterus and some of those, have just sheer blades of lower jaws with
Hmm.
definitely no teeth. But they also have other kinds of stem, we call them stem sharks or stem chondrichthyans.
Hmm.
I'm very loose with the term, as you see in the book, because I'm trying to keep it simple for the lay reader. But I do give the definitions in the back of the book, what are more precise scientific definitions. Acanthodians, of course, are what we call stem chondrichthyans. They're on
Yeah.
the side branch leading to main chondrichthyans. But some of them at the base of that branch must be more similar to chondrichthyans than the others. So
Hmm.
what we find in the fossil record are generally the ones that are more specialized away from the basic shark body plan,
Hmm.
which, as you said, is absolutely correct. I find that whole area fascinating, and I got hooked on stem chondrichthyans right from the start. One of my very first papers I ever published in 1983 was on a new kind of stem chondrichthyan, a new acanthodian from Australia called Calmacanthus, which has
Hmm.
since been elevated to its own suborder within the Diplacanthidae, Oideae or whatever. And it's been found all around Antarctica as well as Australia. But yeah, they're a very fascinating group, and there's very few people working on them. Carol Burrows doing amazing work in Australia, and some of the old specimens are being reanalyzed in terms of scanning and CT work to reveal more about the brain cases, and that's what we need more of to find out more about them.
Yeah. Yeah, I find that the most interesting too. Out of all of the Chondrichthyan topics, like as cool as Megalodon is, and
Mm,
some of the large Cretaceous lamniforms, I find that the closer to the base, the more interesting because there's more ambiguity with it. Like all of the lines are murky. Because if you think about the concepts like punctuated equilibrium, where you
yeah,
have like long stagnated periods and
yeah,
then transitions or just like a glimpse of time, where you're
yeah.
trying to find those little glimpses
Yeah,
in what we can. So it's really difficult, but that's I feel like where the most interesting stuff happens.
definitely. Down the base of the tree of evolution, of like an evolutionary tree of vertebrates, are the bigger questions to solve and the bigger answers that resolve, where everything fits into the evolutionary story. Not just macroevolution in terms of the body shapes and skulls, but microevolution is equally important with how tissues have evolved.
Yeah.
When you look at things like lungfish, for example, there's like many different kinds of dentine they evolved in the Devonian that other creatures didn't, because they were experimenting with tissues. And same with sharks, experimenting with enameloids. Some teeth don't have enameloid caps in the Devonian and others do. And then multi-layered enameloid, which defines the Neoselacians later on, became a super strong tissue for teeth that really made sharks take off in a big way.
Yeah. And the histology is a really interesting aspect as well. Like in the book, you talk about with the Neoselacians with the triple layered enameloid. And
Yeah,
I still call it the triple layered enameloid, even though I know that other paleontologists, they call it like something else. I think they use a four layered now. I think
I'll
it's
do that.
Giles
Okay.
Honey. Yeah. But I
I've
mean,
been going with Giles Cooney's book. I've got it right here, actually.
I
Um,
think it was a
yeah,
recent or fairly recent, like within the last like 15 years or so, they're talking about different things because apparently the triple layered isn't like the most scientifically accurate, but since everything's
yeah,
been
yeah,
published using it, it makes
yeah,
more sense to just refer to it as that than the new stuff. Because you're not going
yeah,
to like go back and revise all of the different taxa that have been described with the triple layered or the single or double layered enameloids. It's just unrealistic until we get to that point.
yeah. Maybe
Anyways,
there'll be further refinement of it in future with all these new scanning techniques where, we're developing all the time. It's not just synchrotron and micro CT. Now we've got neutron beam facilitations and other things that are in the works,
yeah.
So maybe we'll get better resolution on all these histological um, defining these characters with new technological breakthroughs, I'm hoping.
Yeah, and I suspect we will because if you recall with Tychodus, initially they were considered a hybodont because for a long time we did an amyloid test and it only had a single layer. But
Yeah,
then a more recent one was done and they found the triple layered. And then that's when everyone was like, okay, this is a shark.
yeah,
This isn't a
yeah,
hybodont. So all of these tests, there is some like room for error where either like weathering on the tooth or
yeah,
like issues with the acid etching or just like not being
yeah.
able to, detect it well. All of that plays a big part in what we consider, the structure of these teeth.
Yeah, and
And
it often comes back to whether someone made one thin section and everyone bases on that, or someone does multiple samples, tests it more thoroughly, all that sort of thing, and then we get a bigger, broader picture of the variation that these things can have as well.
yeah. Yeah, for sure. And you also have like some of those murky areas even within the enameloid evolution. Like for example, I think one taxa that you hadn't mentioned in the book are the is the family Anachronicidae,
Ah,
which
yes, synchronicities, yeah,
yeah, which their teeth look very Neo-Selacian like. However, they
yeah.
only have that single enameloid layer, which prompted, a lot of paleontologists to wonder, is this a Neo-Selacian or is this not?
I
But
know, and same with Mcmurdotus, which we've changed to Masiotis. I'm well aware of the Anachronicities paper by Chris Duffin and David Ward from the 80s, and talked to both Chris Duffin and David Ward about it, but in the end, the publisher thought it was too detailed to put such detail in, because
Mhm.
it's more the specialists like you guys listening to this podcast that would
Yeah.
love that sort of detail,
Mhm.
but it would turn the general reader off getting down too detailed in the histology kind of thing. So it was a section that wasn't deemed appropriate to put in the book.
Mhm.
And it is still ambiguous. So if you have too much ambiguity, it doesn't keep the storyline moving quickly along, and that's kind of the reason. But yeah, one of the things that's fascinating is we have these teeth that are several cusps with serrations on them.
Mhm.
Masiotis used to be called Mcmurdotus, but we changed it in a paper in 2021 to honor John Maisie. And these things were also thought to be almost identical to the bramble shark teeth. They're kind
Yeah.
of rhinus. So, they look very, very similar, but the enameloids are not there. So it's can't really, they were thought to be there by Carol Burrow, but then she changed her mind. So yeah, there's all these early experimentations that are almost approaching the Neo-Selacian condition back in the Devonian, but they don't quite get there. So most of the experts that I've been trusting with their advice sort of go back to the Mesozoic as the origin of true Neanderthalians, and that's what I say in the book.
Yeah. Yeah, and with like Mesiotis, for example, I suspect that that is convergent evolution because you have like in the Jurassic, that's when we see your first like true squalian and Gallian sharks. Like
Yeah,
we have sharks in the Triassic that,
yeah,
they're sharks, but they're not like classified within our, set of crown group sharks, if you will.
yeah, yeah,
So the odds of having something all the way in the Devonian that
yeah. It's
already
remote.
resembles an Echinorinus, whereas the earliest Echinorinus we have is like the early Cretaceous.
Yeah.
It's so
No,
unlikely. At the same
that,
time,
that's
oh,
such a good example, Ben, because it's like if you have a big gap, if you have a small gap in the fossil record, anything's possible. But with
mhm,
really, really big ghost lineages, it's highly likely that we're just wrong, that we haven't
yeah,
found and the classic case was Polypterus, the reed fish from Africa, which
mhm,
for many, many decades was thought to be a living Devonian Paleonissoid kind of thing because of its scales and primitive skull structure.
mhm,
Um, but it just didn't fit, because we didn't have a fossil record of them extending back beyond the Mesozoic. We didn't have them in the Carboniferous, the Permian, and so on, which is a big block of time. And eventually that was resolved through Matt Friedman and his team, showing that they evolved kind of in the middle of the Mesozoic, and they're not like long surviving Devonian sort of fish. And
yeah,
so often that's a classic case where the fossil record was correct. And the same with sharks, because as you know, we have a brilliant fossil record of sharks from their teeth
mhm,
and loads of samples all through the sediments. And so we can track the living shark families and groups very accurately back into where they first sort of originate. And if there's not too much of a gap at all, I
yeah,
think it's a wonderful record of sharks based on teeth alone.
yeah. Yeah, for sure. And it is really interesting that you really don't see anything that resembles a crown group stuff in the Triassic. I mean, there could be the case for Pseudodilatius, but I
Yeah.
suspect that that's really weird convergence too. It's,
Could well
but
be,
then,
yeah. I kind of leave that open in the book.
yeah,
I looked at those little jaws, and I actually have a photo of Pseudodilatius from the
yeah,
Triassic with a modern Delacius jaw next to it, just
yeah,
to show that, oh, they're so similar, aren't they? But
yeah.
you're right, it could be convergence. We won't know until we find a whole complete one, like we did with Tychodus.
Yeah, apparently there is a whole complete or two whole complete anachronistids that were found in Bear Gulch that haven't been described. I feel like
Wow,
those, I feel like those would probably be like one of the biggest papers of the decade if they actually get done because then you get
absolutely.
like
Yeah.
the shapes of the first true Neoselacians or something else. Who
Yeah,
knows?
yeah,
But
no, that's very
yeah.
exciting. I didn't hear about that. Well, I did speak to both Dick Lund and Eileen Grogan, going through the process of writing the book on email, and I know they're just sitting on so much amazing material there that hasn't been published. But lots of young people are coming in and working on. I know JP Hodnett is working on some of that stuff at the moment.
Mhm.
So hopefully we'll get some exciting discoveries out in the near future from more from that site.
Yeah. And I'm hopeful of that too, especially when they hinted at the Chamatotus, Lysgotus,
Yep,
Venestotus
yep,
all being found
yeah.
in one jaw. That's
Wow,
such a
wow.
such a cool
Well, that's
help.
one of the things I talk about in the book about the science of paleontology when you're working on these sort of fossil sharks. It's not always the excitement of finding a new species all the time. A lot of
Mhm.
it is the hack work of cleaning up the mess of the older paleontologists, such as like with discoveries like Cladodus, which was a tooth commonly found in the Carboniferous, big cladodon type teeth, like
Yeah.
Tenacanthus type teeth. And originally there was like over 70 different species of Cladodus, but Michael Ginter and Chris Duffin actually sorted out into just 5 valid species plus Savardus, which they named, which is, as we know, the biggest tenocanth or predatory shark of the Paleozoic.
Mhm.
Um, so it's exciting that you have to document that there is the fun stuff, finding new species and describing new forms, but there's also you've got to do that hack work. You go back and just clean up the mess of earlier paleontologists and make sure that the taxonomy is clean for the next generation to build upon.
Yeah. Yeah, for sure. There is a lot that needs to be cleaned up. Like for example, if I'm reading through publications and you'll see things cited because they have to be cited, but at the same time you're thinking, was Carcharodon taurus around in the early Paleocene or was this a different species? Like
Yeah,
you have to wonder, but then at the same time you have to cite it because
yeah.
it was already done. So
Well, you
it's
cite it, cite papers like that in research, but you can write a cautionary note
yeah.
when you cite it, like sort of, is this correct or not? Or the good thing about writing a book like the one I've just written is I've got an extensive section of notes at the back, and I didn't just list references like in a scientific way. I just do it in a chatty way where you can say, well, I use this paper to cite this information. But I have my doubts or blah, blah, blah.
Mhm.
And I give my own personal comments on it so the reader can
Yeah.
read that paper with a little bit more information than, say, just citing it.
Yeah. Yeah, one of the things I did enjoy about the book is it's it's an intermediate between like a true publication where you have a lot of the really rich knowledge, and then it's also palatable like a, regular book that you'd get off the shelf. So you have like the best of both worlds where if you could get, a shark nut like me or, the people that listen to this and they'll like
Yeah,
dig deep into it, they'll form their own opinions, they'll like,
yeah,
try and cross-reference you. But then you'll
yeah,
also have people that might just love sharks but not really know much about them, and they'll be like, "Oh, that's pretty cool," and they'll leave it at
yeah,
that.
yeah. Yeah, well, it is based a book for the wider audience to give the big overarching view of shark evolution. And, as I said, I could have written 1,000 pages on it if I just kept going.
Yeah.
But you can't have too much detail or it puts too many people off even picking it off the shelf or buying the book or reading it. So, yeah, I've tried to compromise. And obviously, a lot of scientists will think I haven't put enough detail in. Some members of the public might think it's too technical, but
Mhm.
it's there. It's meant to be the Goldilocks book that suits the vast majority of people that want to know about the topic and be entertained at the same time while they're reading the book.
Yeah. And what I'd have to say for that is if you're really interested in the sciencey stuff, just read the publications that the information comes from, because then you'll
Yeah,
have all the science stuff that you'll want. But
yeah,
then this book is, I think, more of informative entertainment, if that makes
yeah.
sense. So
Well, that's
like,
what a popular
yeah.
science book's meant to be.
Hmm.
And it's telling the science through stories, both the stories of people, the stories of discovery in the field, including some of my own discoveries, like finding the Gogo Salakis after 60 years of people searching at the Gogo sites in Northern Australia. I
Hmm.
remember the day clearly. I picked up a nodule, I hit it with a hammer, and I could see little teeth. And I knew I'd found the first shark ever from this site, which yielded three-dimensional uncrushed remains. And then I tentatively put the shark into acetic acid, very low doses, and I found that the cartilage was mineralized enough to actually get the cartilage out of the rock without it falling apart. And then we got about 80 teeth and scales, and plus the jaws and the shoulder bones, the scapulocoracoids, to name a new shark, Gogo Salakis. That was really exciting for me, but equally as exciting is finding new sharks in Thailand in the Golden Triangle. And I also collected sharks in Iran back on a field trip back in 1999, which
Hmm.
is I had that in the book and they cut it out, but I put it in the notes at the back so you can still read a couple of paragraphs about collecting fossil sharks in Iran back in
Hmm.
those days, which I named a new species, Dalmaiotis, with Cartilaginous. So yeah, I've had fun in the field and I still do, but it's the greatest thing to go out searching for something and then finding that one in a million kind of fossil that you never expected to find. And it's still the only proper shark from Gogo we've ever found. We've found a couple of other stem sharks that we're
Hmm.
working on, and they've been nicely preserved as well. But I still go back and I'm still hoping to find another one more complete.
Yeah. Yeah, no, it is really cool. I love going in the field too. Granted, I've never found like one of those, I guess, one in a million finds like you did. I still find some isolated teeth here and there in the Paleozoic of Arizona, which
Yeah,
is I just love the Paleozoic. There's so much diversity in the
there
fossils,
is.
especially in the chondrichthyan world.
Oh, let's talk
It's
about
just unmatched.
tenacants for a while. They're one of my favorite groups.
Yes, let's
Um,
do it.
and I can tell you something that's new information. I'm sure it's hinted at in the book. Um, towards the end of the Devonian, when you get to the last couple of million years, you get like the Cleveland Shale of Ohio and New York State, and also Morocco. You've got some amazing fossil sharks coming out of Morocco. And Christian Klug, who's been finding and describing those sharks with Mike Coates and others, he came on my last GoGo expedition just the last few weeks. And
Yeah.
it was fantastic to have him there and talk sharks every night around the campfire kind of thing. And he told me that in the book, I mentioned he's found a very large new tenocanth, absolutely gigantic, you know.
Mm-hmm.
And then recently he's acquired 2 skulls of this that they haven't published yet, but they're writing the paper up right now. And the skull and the branchial arches are over 1 meter in length.
Mm-hmm.
This was a really big, ferocious tenocanth right at the end of the Devonian. And there's no placoderms, even Dunkleosteus, I think, that would have been bigger and more mass than this shark. So I think right at the end of the Devonian, sharks were starting to overtake the placoderms and become the dominant apex predators. It just seems like there's more species, for example, of sharks than there are placoderms in the Cleveland Shale.
Mm-hmm.
And same with other sites in Europe and even Morocco, the sharks seem to be the dominant group. So it's very exciting that, you know, from writing this book, I got these new ideas and I ran them by people like Mike Coates and Christian Klug, and they kind of agreed. And so I could put these like ideas in the book just to sort of make people think from a new perspective about,
Mm-hmm.
you know, that it wasn't just placoderms until they died out, then sharks kind of took off. There was a sudden rise of sharks towards the end of the Devonian and a decline in placoderms before the mass extinctions at
Mm-hmm.
the end. So I think this is kind of a new idea, a new fresh perspective on it.
And how did this coelacanth compare in size to the Carboniferous Cyvodus, for example?
Well, the lower jaws, we also have one from the Cleveland Shale. It hasn't been described. That was thought to be a Titanichthys, a placoderm lower jaw, but it's definitely a coelacanth, and that's about 60 centimeters. I don't know what that is in inches, and a couple more than 2 feet long kind of thing, 2.5 feet, something like that. So it's pretty big. The one in Morocco is even bigger. It's a much bigger jaw and skull. So we're thinking of a fish at least 7 to 8 meters, maybe 24 feet, something like that, 26 feet. So it's
Mm-hmm.
getting up there, Sabota's size. It just depends on how you calculate the true body size of Sabotas. I know JP has an amazing specimen in the Mammoth Cave in Kentucky that's in the wall
Yeah.
with the jaws complete, 2.5 feet long and the big teeth. But he
Mm-hmm.
says that's not the maximum size. It's just a large one, not the maximum size of the teeth are much bigger. So again, speculation, we think Sabotas was probably up to 24 to 28 feet long. That's the opinion of the various experts I've asked, including JP.
Mm-hmm.
So yeah, that's a hell of a big shark.
Yeah. Yeah, and also in the Devonian, for example, they talk about Dunkleosteus being this massive animal, but recently they were shrunk down significantly too, which all of
Yeah,
a
right.
sudden leaves a lot more room for these potential and now found large Devonian
Yeah.
coelacanths.
Now, I did cite that paper by Russell Engelman that
Mhm.
downsizes Dunkleosteus, the Chunky Donkey paper.
Yeah.
But talking to some of my other colleagues, especially Lawrence Salan, who's an expert in these things, based in Okinawa these days, and some other experts, they're starting to doubt the method of how it was shrunk, and maybe the happy medium is that Dunkleosteus was between 15 and 20 feet long maximum. One of the things is that the tail is very short. It wouldn't have had a tuniform swimming style unless it had powerful bones in the tail, and placoderms just lack that tailbone. So there's a number of reasons. We think it might have been slightly bigger now, but certainly not as big as the biggest coelacanths living in the late Devonian.
Hmm.
Um, yeah.
Yeah. It's interesting and it'll always change, kind of like the Spinosaurus debates where every 2 weeks there's a new opinion.
Yeah, well, a number of papers were published on calculating the maximum length of Dunkleosteus. As you know, the maximum one was Umberto Ferron and his team from Spain came up to like 7.9 meters, 25, 26, 27 feet long. It all
Mhm.
depends on the length of the tail, which we don't really know for that group because we only have the dermal armor. But some placoderms have dermal armor and a really, really, really long tail, like some of the phylolepid placoderms I
Mhm.
described from Australia. And others have long armor and a really short tail. So there's all sorts of possibilities, shall we say, of what the real shape of the tail was like for Dunkleosteus. I recently found a placoderm at Gogo on this last trip, just 2 weeks ago, which is an Eastmanosteus, which is a relative of Dunkleosteus. And I found one in a nodule with a really long trailing tail coming out. So hopefully when we prepare that specimen, we might get some really good data, new data on the tail shape in these kind of placoderms.
Mhm. Yeah, that would be really cool. I mean, it's I love the science, but it's so sad that one of my all-time favorite childhood animals, Dunkleosteus, is now.
We don't know. It might have been bigger than you think.
Yeah,
Let's wait for the next papers on it. I'm sure
yeah,
people are
I'm
writing
really
right
excited
this
about
minute.
it.
Yeah, yeah.
Yeah.
But back to sharks. I mean, I'm glad you like the book. There is a lot about the Mesozoic sharks as well, but
Mhm.
the biggest, most spectacular shark of the Paleozoic has to be. What do you think?
Of the Paleozoic is probably Helicoprion.
Yes, Helicoprion. I reckon that's one of my favorite sharks of all time because it also occurs in Australia. And I went to the site where the first Helicoprion remains were found back in the 80s with John Maisie actually towing along. And we
Hmm.
didn't find any more Helicoprion, but we found some poisonous snakes in the rocks there, which we had to watch out for. But no, Helicoprion. I based a lot of that chapter on interviews with Leif Tapanilla, who's doing amazing work with his team, Jesse Pruitt and others
Hmm.
in Idaho, where the best tooth whorls come from. And not only that, but some of these tooth whorls are in blocks that have parts of the skull and brain case and jaws and jaw cartilages preserved. So it's all this new amazing work with the CT scanners that's starting to reveal the truth about this Helicoprion, which for our readers, listeners, I mean, most of the people listening, if they're elasmobranch nuts, they'll know exactly what Helicoprion is. It's got this big buzzsaw shaped lower jaw of tooth whorls. And some of these teeth are up to like 4.5, 5 inches high. They're serrated. The tooth whorls can be up to sort of 2 feet across, 2.5 feet across for the largest ones from the Phosphoria Formation of Idaho. So a really big shark. And Leif he's quoted in the book, he says somewhere between 33 and 39 feet in length. So the largest predatory shark from the origin of sharks through to, say, Megalodon, which appeared much, much later.
Hmm.
They lived in the Permian about 280 million years ago and reached a peak of size and then went extinct slightly after the Triassic extinction, the end Permian Triassic extinction event. We
Hmm.
get Helicoprion goes extinct, of course, but we get other members of this group, the Agassiodontidae, living into the early Triassic of British Columbia. Then they go extinct. So they kind of just straggled through that extinction event, but then didn't make it beyond the first few million years of that event.
Yeah.
But we've long had the mystery of what did Helicoprion eat and how did it feed? And the recent papers by Leif Tapanilla and Jesse Pruitt sort of argue convincingly it was a cephalopod specialist that ate squid, soft squid, and not things in a hard shell because they said there's not much tooth wear on these teeth that would be implicit if they were cracking large ammonite shells, for example. And
Hmm.
then I talked to Christian Klug in the field, who is a cephalopod expert. You know, he studies Paleozoic cephalopods. He's a world expert, and he said that's a nice theory, except for the fact there were no squids around in that area at that time, not that he knows of. You know, so maybe because there's not a good fossil record of them, but certainly has no evidence of large squids in those same seas. But then again, what about if Helicoprion was such an efficient predator that, as has been suggested in some of the papers, that its lower jaws, when they opened, would sort of had a quadrate like a snake quadrate. That's the bone that articulates the lower jaw to the skull. That could slide back and push the lower jaws forward, then slash it backwards. So it could grab a squid-like creature and maybe pull the squid part of the ammonite out of its shell to eat it without having to crush the shell. So that seems to be a very likely possibility, and it kind of explains that it had an abundance of food, but it didn't need to crack the shells and wear its teeth out at the same time.
Hmm.
But you know, we'll never know until we find maybe a whole complete helicoprine with stomach contents, which
And do
might
we
turn up today.
we
You never
find
know.
Do we find any really significant wear facets on any of the Helicoprion specimens?
No, that was one of the key questions I asked Leaf, and he said he's examined thousands of individual teeth of Helicoprion on many whorls, but he's only seen wear on 3 or 4 of them. So they don't. Whereas things like Adestus, which our good friend Wayne Atano has studied and done some amazing work with,
Mhm.
that shows wear of the tips of some of the teeth. So there's clearly you get breakage of the tips of sharks when they attack hard prey, like with white sharks, with some of the tenocanth sharks, like Kaibab venata that JP Hodnett described. And you get this in Adestus, but you don't get it in Helicoprion. So they might have been eating more harder food, like either fish or ammonites.
Yeah, I talked with JP Hunnett. He was actually on the podcast before, and he was
Yeah,
saying how Helicoprion was, the big bad eugenodont, but yet Odysseus was the one that was, really eating the difficult prey. So
yeah,
he thinks that they took on like a coelacanth type of role in the ecosystem in between the large coelacanths that came before it and then the coelacanths in the Permian.
yeah,
That,
yeah. No, that
they
makes
were
sense.
hmm
There are
Yes.
so many varieties of these things like sarcoprine as well and others that, they're a whole specialized group that ate really specific kinds of prey. We just haven't figured out exactly what all the other ones were doing as well as we know with both helicoprine and Adestus.
Yeah. I have a really funny story too. You talk about the Steve Alter situation with the Helicoprion that he had in the book. And
Yeah.
when I was little, I think I was like 7 or 8 at the time. So my all-time favorite stuff was Dunkleosteus,
Yeah.
Stethecanthus, and Helicoprion. So
Of
being,
course.
so being that young, I just thought, it's just another old tooth. So I emailed Steve Alter being like, "Hey, do you have any Helicoprion teeth for sale?" And then
Yeah.
and then he was like, do you have $1 million?" And I was like,
Right. Yeah.
"No." And I lost all hope for getting one, for decades. And I
Yeah.
see him at the Tucson Fossil Show after I moved to Arizona. This was only like a year or two ago that I talked with him about this, and he was like, "Oh, by the way, like not too long after I got that email from you, I actually did get a Helicoprion."
Yeah.
And then he talked about the confiscation and everything. But I mean, it was just so funny, like reading that story and then
Yeah.
relating
Yeah.
it
Yeah.
to when I was a
Without naming
kid.
without naming names.
Yeah.
Yeah, no, that story featured in one of my earlier books published in 2002, The Dinosaur Dealers, about the illegal fossil trade. But it was such a great story how Helicoprion holotype was missing from the Russian institute, the PIN, Paleontological Institute.
Hmm.
And then it turned up that it was offered to a dealer in America, and eventually Dave Ward was able to arrange to get it back to the collections in St. Petersburg.
Hmm. And you also have a really interesting take on like commercial dealers and everything in your book that you discuss, that a lot of the major breakthroughs have been found by either commercial dealers or amateur paleontologists, people that
Yeah,
don't really have the degrees or anything, but they
yeah.
found all of this stuff. And I feel
Mm.
like there's a big disconnect between a lot of paleontologists and the private sector when it comes to the relationships between the
Yeah.
all.
Um, I don't have a problem with it, and I work with a lot of these people. I have in the past, and so people like David Ward, who's trained as a veterinarian, and Gordon Hubble, who's also trained as a veterinarian, have both become really important people in the discovery of fossil sharks. And with David Ward, he's written over 100 papers naming many new species and doing detailed work. Um, the only issue is when the specimens end up in private collections, because uh, part of the work of science is that everything must be testable. And for paleontology, it's not so much doing an experiment like a chemist, it's having the specimens publicly accessible in a proper museum collection so that if someone
Mhm.
doubts your work, they can go and look at that same specimen and make their own assessment of it. So the really good private collectors and dealers actually work with the museums and will donate material if it's scientifically important and needs to be published on. And
Mhm.
that's the way it should be. We should not have specimens described that are kept in private collections
Mhm.
because then they're not publicly accessible. And if those people lose their fortune and their collections are sold off, we don't know where that specimen will go or
Yeah.
what. Charles Darwin's a classic example of that, because when I was working in Museum Victoria, we discovered Darwin's lost Cretaceous barnacle collection. That
Mm.
he described these new fossil barnacles, but they were disappeared off the face of the earth. No one knew where they went to. And then they turned up in Victoria, Australia, in the Museum Victoria collections, and they matched identically the plates of Darwin's originals. We found out that Darwin used to borrow these collections from private individuals and write the papers and then give them back. And
Mhm.
then this private collection ended up bought as a job lot for Museum Victoria, came out to Australia. And that's where his holotypes of all these fossil barnacles ended up. So
Mhm.
not all of them, but quite a few of them. So, it's good that that collection eventually made its way into a proper museum so other people can now go and study those specimens. But
Mhm.
I don't have a problem with shark's teeth, especially because they're so abundant and they're mined by the millions in places like Morocco that
Yeah.
they should be freely available to people to buy and research, and to encourage kids to study paleontology and collect fossils.
Yeah.
I have one right here, actually. It's one of my Bigototus obliquus teeth that I bought recently from a shop in Australia. Quite
Mhm.
a nice big one.
Yeah. Yeah, there are a ton of sharks, and the vast majority of fossils that are sold are of no real scientific value. Like, for example, you see tons of the sharks and the other Moroccan stuff, like the
Yeah,
Kem dinosaurs. Most of them don't really have any real scientific value. And then you have the bigger gray areas, I think, with like the complete dinosaur skeletons. There was the whole apex thing that happened recently that people are talking about right now.
yeah,
But yeah, I
yeah,
mean, in order to get the public interested in this stuff in the first place, a lot of that happens with finding or buying their first megalodon tooth. Like museums don't
yeah,
really need many more megalodon teeth. Like they find thousands of those things every year diving off like the
yeah,
shore of North Carolina and stuff. But
yeah,
that one fossil could lead to somebody pursuing a career in paleontology or getting
yeah.
super entrenched into the subjects.
Yeah, and it raises a good point there, that I think museums should be purchasing or acquiring more larger collections of shark's teeth so that the quantitative work can be done. A lot of museums do have big collections of fossil shark's teeth, but we think of things and we think, well, when Catalina Pimiento did a study of megalodon teeth based on collections, she had, um, I think, about 1,000 teeth or slightly less to work with.
Mhm.
Whereas if you had 5,000 or 10,000 teeth, you could do much better mathematical quantification of those studies,
Mhm.
So it is up to people that study these sharks to make sure they get good collections and they're registered in a museum so that the
Mhm.
data is there for other people to check later on.
Yeah, it
I
is a
think
big.
yep.
I was just
Sorry,
gonna
I
say
think
it is a.
I'm running out of time soon, but we can keep going for a few more minutes if you like.
All right. Yeah, I was just gonna say it is a big issue when you have things that are supposed to be donated and that have had work done and then they turn up missing because
Yeah,
then you start having to also question the authenticity of the work in the first place because you have
yeah.
no way of really, corroborating that work. So
Yeah.
it
As
is.
as a I was just going to say, as a kid growing up in Australia, I became hooked on fossil shark's teeth from the age of about 8 years of age. This is
Mhm.
a big Caradon hastalis tooth I found. It's about 3 inches, really big one, an anterior. I think it's an upper. Yeah, yeah, it's slight curvature. It's not really quite perfectly symmetrical like the lowers. But yeah, I had a huge collection of fossil shark's teeth that I amassed from sites all around Australia, about 25 different species. And when I got my first permanent job in paleontology as curator at the West Australian Museum, I just gave the whole lot to the museum. I didn't claim it
Mhm.
as a tax deduction or anything like that. I just wanted it to have a proper home. So that if anything happened to me, that collection was safe and it's in there. And it still is. And in writing this book, I remembered I found a nice Caradon, a Totus angustidens tooth from a site
Mhm.
in Victoria with beautiful serrations, a nice big one from the Oligocene. And I wanted to go back and see it. And they said, oh, we can't find it. We can't find it anywhere. I said, what do you
Mhm.
mean? I donated my whole collection. I had a number on it and everything. Eventually we found it. It was in another drawer and it was handwritten with my label and my handwriting on it, because I was curator of that collection for like 16 years and made sure that my own private fossil collection got properly accessioned into the collection. But it was great to touch base with some of those specimens I'd found and to relive the stories in my mind about finding them, and put some of those stories in the book.
Mhm. Yeah. Well, if you're running out of time, let's think of what's the number one topic that you'd want to discuss before we get off this.
Well, we haven't talked about Megalodon. I know you focused on the Paleozoic, but for readers of the book, Megalodon is an important part of the whole shark story. We can't just
Yeah.
sort of ignore it. But I'd like to focus on what's new about Megalodon in my book compared to other books that have recently come out. And I'd like to say that, um, again, I interviewed people like Catalina Pimiento, who's done amazing work on Megalodon. She's actually done two postgraduate theses on Megalodon. She's done a master's and a PhD. I don't know of anyone else in the world that's done 2 degrees on Megalodon, but she's done incredible work. And one of the things in writing this chapter was to focus on what's new about Megalodon that we don't know. And there was this amazing paper in press at the time by Philip Stearns of Washington University and about 26 other world experts, where they went back and they examined the skeleton of Megalodon that's in the Belgian Museum of Natural Sciences. You know, it's a string of vertebrae, doesn't have any associated teeth, but we know from the size and the calcified large round laminate vertebrae that it was definitely a megalodon, because it couldn't be anything else. And then they discovered that the tail vertebrae were misinterpreted in the original descriptions. And that when you go back and you re-look at it, you see it's got a much longer, more slender tail than we previously thought, more like a basking shark, not like a great white on steroids, which is the way they're always depicted in the B-grade movies.
Mm-hmm.
They also calculated swimming speeds. Kenshu Shimada was part of this team, and also other papers he's done looking at the scales of Megalodon from other sites where they're associated, like in Japan,
Hmm.
and calculated that they had a much slower swimming speed than a great white, more like 1.7 miles per hour. So we're getting a different picture of this thing as a big, more elongated, cruisier kind of shark, not the sort of the terror of the seas with these great teeth. Sure,
Hmm.
it still has great teeth. And we know it hunted whales and seals and other marine mammals because of the fact we've got the tooth scars or sometimes teeth embedded into the vertebrae of the whales.
Hmm.
But the way it attacked might have been quite different. It might have just built up momentum and had less powerful acceleration like a white shark, and just had this massive momentum from its weight. We also discovered recently, we proved that Megalodon was warm-blooded. You know, it was long theorized that it must have been warm-blooded, like white sharks are. They're called tachymetabolic. They have slightly higher body temperatures than the seawater because of the muscle energy that generates heat, and the ret mirabilis, this network of capillaries that exchanges heat from the muscles into the blood, gives them a slightly warmer body temperature. But using this new technique of clumped thermal isotope paleothermometry, um, amazing work has shown that Megalodon definitely had a warm-blooded metabolism, something like 82 degrees Fahrenheit, which would have given it greater range in the higher and lower latitudes, but still no evidence that they could go into really deep southerly latitudes like the Antarctic seas or the Arctic seas. So I think a new picture is emerging about Megalodon that's breaking the mold from what we thought. And all this new research made it into the book before the presses rolled. So I'm really pleased with that.
Yeah. Yeah, Megalodon it's kind of like Spinosaurus a little bit in that that's in like the shark world what's the biggest focus by far of attention. And
Yeah,
and who knows what we'll know like in 2 years from now or what we'll believe in. Who knows in like five. Megalodon is always going to be the center of the spotlight for the shark world.
yeah.
I'm really
I will
excited
tell,
to see what happens
I
with
will,
it.
I will tell you one more story about Megalodon that relates to an Australian find that kind of, I think, is the beginning of the Megalodon is still alive and out there theory. And
Hmm.
it's based on a fantastic shark jaw of a white shark that was caught off the southern coast of Australia in the state of Victoria, where I am here, off a town called Port Fairy. in 1837 or something like that. And eventually it made its way to the British Museum in London. And when Albert Gunther wrote his first catalogue of fishes of the British Museum, he recorded this shark as having a body length of 37 feet, right? That's
Mhm.
huge. I mean, the biggest known white sharks are about 20 feet at the max, but
Yeah.
this was 37 feet. And the shark jaw was kind of big, but not super gigantic, like a megalodon jaw. And this was published in a very respectable journal of the British Museum. So people reading that would have thought, wow, maybe megalodons are still out there.
Mhm.
But John Paxton, an American ichthyologist who was working at the Australian Museum for a long time, came over and visited the British Museum, and he measured that shark jaw and the teeth, and he calculated it based on living specimens that it would have only been about 16 or 17 feet in length. Now think of that, 17 feet versus 37 feet. We think it might have been a typo or even a prank that changed that 17 to 37. But the funny thing was, when they reprinted the British Museum catalogue again a few years later, they rounded it out to 40 feet. So they
Mm.
said this shark was 40 feet long. So it's even getting bigger as the book's reprinted. So I think there's an element that maybe people who want to believe Megalodon's still out there have turned to this and said, well, if the British Museum authoritative publication says there were 37 feet white sharks out there, it's likely they were a megalodon and not a white shark. But no, when you look at the jaws, it's definitely a standard but large kind of white shark.
Yeah. Yeah. Well, I'm thinking for a closing statement, since we talked about the past of sharks, we
Yep.
talked about Megalodon. I think that the next thing that we should close off on is what the future of sharks looks like.
Yeah, it's a bit of a worry, as we all know. There's about a third of all shark species that are in the endangered or kind of threatened part of the spectrum. And there's about 180 or close to 200 species that are more vulnerable and extremely endangered. And a lot of this comes down to just simply overfishing. It's like the shark finning industry that, as we know, kills 70 to 100 million sharks a year just for their fins. That this should be banned and stopped. It's just cruel.
Mhm.
We can sustainably harvest certain species of sharks that are abundant, but like all fishing for tuna or salmon or things that we like to eat, they have to be regulated. So we have to understand the population dynamics and how much of that population we can safely take that's sustainable for it to keep reproducing and maintaining its population. But sharks aren't a major food source as much as the bony fish, obviously. I think the future of saving sharks comes down to enforcing the regulations around endangered and CITES endangered species, which just doesn't happen in many other countries, that they don't enforce these regulations. The other thing is so many of these sharks are caught as bycatch to the big ocean trawlers that go out fishing for deep sea bony fishes that we like to eat. They catch thousands of tons of sharks by accident that die and don't get thrown back.
Mhm.
So we need better regulations around how this is reported, how we can check what the bycatch is, and how we can stop that and put in mechanisms that things that are caught that are rare, endangered, get thrown back immediately, not just killed.
Mhm.
That's kind of wishful thinking, because I can see it's going to be very, very hard to enforce in reality.
Yeah.
But one of the saving graces that I end the book with is the growth of shark tourism, which is just an amazing thing. All around the world now, you can go and see sharks in the wild. I went out to the Neptune Islands and went in a cage to see the great white sharks. It wasn't just a quick trip. I spent 4 days out there, spent a total of 9 hours in a cage watching about 8 different sharks. And it was just blew my mind how amazing they are to just watch, just sit there. One day I was in the cage for 2 hours without getting out, because my first photo on the GoPro was at 9 o'clock and the last one was 11. I took video as well, and they win you over. They're just beautiful things to watch. They're just so graceful and powerful. And one leaped out of the water and crashed against the cage, and it's just the most awesome thing to see these
Mhm.
sharks. And since then, I'm 67 this week. Actually, my birthday's on Friday. I got my scuba diving ticket about 3 months ago off Lord Howe Island in the Pacific, and I
Mhm.
went swimming with Galapagos sharks, which was fantastic. and
Nice.
filming them on my GoPro. So I want to go out and see more sharks in the wild. You can do experiences of Florida and the Caribbean to see tiger sharks and hammerheads and even bull sharks off Fiji and different places. And, safe environments with big groups of people and people that know how to sort of wrangle the sharks so they don't come too close. I think, and swimming with basking sharks off Ireland and Scotland would be amazing. Big schools of basking sharks. All of this shark tourism is increasing rapidly, and
Mhm.
it's worth over $400 million a year now globally. And the whole shark food market is thought to be about 800 million to a billion. I reckon soon the dynamic's going to switch, and sharks will be far more valuable alive than dead as food.
I hope so.
Yeah, so go out and do a shark tourism thing, support the shark industry, shark tourism industry. By doing it, you learn more about sharks, you become more passionate about them, and you pass on that enthusiasm to other people. It's the best thing in the world. I want to do more swimming with sharks in the next few years.
Yeah. Well, I
Okay, go.
appreciate having you on, John. Congratulations again on your book. And where can everyone find this book?
Oh, thanks, Ben. And it's been great talking to you. You've asked some really great questions and you clearly know your fossil sharks. So the book is available just about at any bookshop. It's on Amazon, Barnes and Noble, Target, Walmart, whatever. You can order it online or you can go to your favorite bookshop and order it in. Um, it's available currently all through North America and Canada. And it's just been released in Australia for Australian listeners. It'll be out in the UK early next year, and there's a number of foreign language editions already in the contract. So hopefully everyone will be able to read it in their own language by next year.
Awesome. Awesome. Well, take care, John. It was great having you on. And yeah, for everyone, don't forget to like, comment, subscribe, all of that stuff. And yeah, we hope to have you on again at some point.
Okay, thanks, Ben. It's been great talking to you.